the James Webb Telescope is shaking our laid-out suspicions. Webb has already recognized an entire series of systems that are excessively large and gigantic for their early development. This raises a significant issue. Have we previously miscalculated in our models of early cosmic evolution? Might we have misunderstood the start of the universe too? Although the Big Bang theory has long been accepted, it is now undergoing increasing scrutiny. It's possible that the Big Bang was not the beginning of everything, that it was in no way, shape, or form the vast beginning signal, but simply one of an endless number of stages. In this context, the next intriguing question is, did anything exist before the Big Bang? Our entire universe was in a hot, dense state then. Almost 14 billion years ago, development began. Not just fans of the geek sitcom The Big Bang Theory know how the birth of the universe occurred. According to our current understanding, the frequently cited Big Bang describes the event in which space, time, and matter arose out of a singularity around 13.8 billion years ago. This set the stage for all that used to be, is today, and will be in the future. So far, so liberally accepted. Yet, how can we possibly know today what happened around 13.8 billion years ago? Well, it's quite simple, by observing an expansion that began with the Big Bang and continues right up until now. As is notable, the universe is in no way a rigid, eternal entity, rather, it is a dynamic system that has been expanding continuously since the moment of its creation. For a better understanding, it should be mentioned that the universe isn't expanding into a pre-existing space. Instead, space itself is constantly growing. If we now trace the universe's expansion backward in time with the help of Einstein's general theory of relativity, we eventually arrive at a point where the density of matter and energy is infinite, and spatial distances are zero. Thus, we have counted back to the hot, dense state from the theory of the universe's origin. However, the theoretical calculations are not the only factors that have helped the Big Bang theory to its currently prominent position. There is also the cosmic background radiation, a form of radiation in the microwave range that was created about 380,000 years after the universe's inception. This radiation still fills the entire universe today, and since its existence was theoretically predicted by the Standard Model, its actual detection is considered crucial evidence for the Big Bang theory. Nevertheless, despite all the numerical models and found radiation relics, we must not overlook that the Big Bang also raises more questions than it answers. For instance, according to our understanding, the early universe must have undergone the first significant expansion phase in fractions of a second, expanding by a factor of 1, 0, 30, 10, 30, 2, 1, 0, 100, 10, 100. In this ludicrously short time frame. Yet how exactly this so-called cosmic inflation happened, and whether it truly happened, is just as unclear as the next question: was there something before the Big Bang? Indeed, the theory of how things came to be, by itself, can't resolve all cosmic mysteries. For example, there is the question of what actually occurred at the genesis of the cosmic birth. In other words, what caused something to arise from nothing 13.8 billion years ago? Was there a trigger for it, or was it pure coincidence? And how could matter emerge from nothing at all? Well, Stephen Hawking approached this complex subject in a manner that was both straightforward and logical. The genius who passed away in 2018 was quoted as follows: "The question of what was before the Big Bang is just as meaningless as asking what lies north of the North Pole. Since time itself only began with the Big Bang, this is an event that cannot have been caused by any person or thing. The laws of nature themselves tell us that the universe could have appeared without the need for energy or a cause." However, other specialists strongly dispute this assumption, but more on that in a moment. No less controversial is the topic of why matter and radiation are so evenly distributed in the universe. Regardless of which direction we look or at which distance, on a grand scale, cosmic gas, nebulae, and radiation all exhibit similar densities and distributions. Current explanations highlight cosmic inflation as a reason. Yet, some scientists propose that this process continues to this day and that many parallel universes have formed in the process. The Big Bounce hypothesis acts as a sort of interim conclusion. One might say that, despite its overall acceptance, the Big Bang is anything but uncontroversial and that we are still far from fully understanding its history. Over time, several alternatives have emerged that attempt to explain the question of the cosmic beginning in a completely different way. And even though the corresponding theories sometimes vary radically from each other, they still share an essential common trait: we must abandon the notion that the Big Bang was the start of everything. If there was another universe before the Big Bang, then the Big Bang was simply a hazardous transition from one universe to the next. Thus, it would be more accurately described as the Big Bounce. But what exactly does that mean? Are there any substantial signs that support the existence of such a recurrent universe? On a fundamental level, the idea of the exchange between annihilation and rebirth is far from new. The early Indian Vedas, for instance, describe the universe as a succession of creation, destruction, and recreation that repeats itself endlessly. The Maya had a very similar perspective, and Einstein himself spent some time contemplating the possibility of an oscillating, recurrent universe, considering it very plausible. In line with the saying, what expands can also contract, cyclic models are still quite popular in cosmology today. This is hardly surprising since this approach avoids the issue of causation. If matter has always existed in an eternal cycle, the question of how something can emerge from nothing becomes irrelevant. In this case, the strange uniformity of the universe could also be explained by infinite withdrawal, which disseminates basically everything. Similarly, the trigger for the huge explosion would be as simple to find. It was basically the finish of the past cycle, which was trailed by another period of extension. So everything could be so straightforward if not for the issue of entropy. As per the second law of thermodynamics, the degree of confusion in a closed framework generally increases, and this also applies to the universe. Because of the always new cycles, entropy would hence need to increase perpetually. This actually means that with each inestimable fresh start, somewhat more radiation is created compared to matter, and that the universe will eventually arrive at a state of maximum entropy in which neither molecules nor stars nor worlds can exist. However, that is not all. Because of the entropy issue, more and more disordered particles would be pressed together with every constriction of the universe, while the following new beginning would be accompanied by a more robust dispersal. Alternately, this means that each new cycle would continuously endure somewhat longer than the previous one. However, this would also imply that the cycles are getting increasingly shorter the further back we look. Just as with the theory of the universe's origin, we would also arrive at a starting point where everything is concentrated, the absent-mindedness of the universe. So, might we at present record the cyclic models away? After all, the corresponding speculations unequivocally prohibit a primitive start of everything. Well, we shouldn't dismiss the possibility of a timeless cycle so rapidly. In fact, researchers have now figured out how to settle the entropy issue, and all that is necessary is a universe experiencing an extreme form of cognitive decline. To figure out what this means, we need to take a brief diversion into the universe of loop quantum gravity. According to this hypothesis, and in opposition to Einstein's suspicions, the fabric of spacetime isn't continuous but is rather divided into small, unbreakable units. The anonymous loops have a degree of 1, 0, minus 35, 10, minus 35 m, which corresponds to the Planck length and thus the smallest possible unit of quantum theory. Collectively, the interconnected loops structure the essential design of the universe, with the particles representing the hubs of the net-like build. In this sense, we can envision the universe as a singular floating of continually changing small associations that are neither apparent nor substantial to us. In this context, the original peculiarity of the universe cannot have existed. Loop quantum gravity only permits for limited actual qualities, which means that infinite density isn't allowable. Simultaneously, however, the quantization then causes an event that is no less dramatic. At the point of the Big Bang, gravity is reversed. Rather than applying an attractive force, it unexpectedly pushes everything away. Consequently, space is for all intents and purposes turned inside out, which has some astounding outcomes. In this manner, the loop model literally shouts that the Big Bang was not the start of everything. Rather than the theory of relativity, it also yields substantial numerical outcomes before the Big Bang. So, there could truly be a major bounce in which a forerunner universe implodes in on itself and is then driven back into larger scales by the countergravitational impact of its own minuscule organization. Conveniently, the subsequent fluctuations in matter and energy density would delete all information from the past universe. As such, every new universe experiences a serious instance of memory loss, which, in turn, also provides an answer to the problem of entropy since it is essentially reset to zero. The universe can remove its old entropy entangles and start anew. Lightheartedly, go ahead and start stirring things up around town. Like and subscribe to become a part of our community and never miss a new video from us again. We'll see you soon.